Welcome students, welcome to the class of hydraulic engineering. So after deriving the flow through circular channel, now let us talk about most economical circular section, okay, or most economical circular channel. So the thing is, earlier in the rectangular channel and trapezoidal channel, for a most economical, either for a rectangular channel or trapezoidal channel, what condition we have used? We have to use the condition that the wetted perimeter should be least as possible. The wetted perimeter should be least as possible. That was the conditions which we have used for rectangular channel and trapezoidal channel. But in this case, in the case of circular section, most economical circular section, it is dependent upon two criterias. It is related or it is dependent on two criterias. The first criteria is conditions for maximum velocity. First condition is condition for maximum velocity condition, and second is condition for maximum discharge. Based on these two criteria, maximum velocity and maximum discharge, we decide the most economical circular channel. Based on this condition, we decide most economical circular channel. But this scenario was different for rectangular and trapezoidal channel. For rectangular channel and trapezoidal channel, we have only considered wetted perimeter, but for circular section, economical circular section, we are considering both maximum velocity as well as maximum discharge. As you can see onto your screens, the figure for circular channel is given onto your screens, okay, where D is the depth of flow or depth of water through an circular channel. 2 theta. In the figure you can see only theta, but AB is nothing but surface of the water. In this diagram you can see AB is surface of the water. This AB is this point A and this point B is surface of the water. This surface of the water is making an angle 2 theta. This red line which you can see, this is how much? 2 theta. It is making an angle 2 theta with the center of the circular channel. The surface AB is making an angle 2 theta with the center of the circular channel. So R is the radius of the channel and I is the slope of the bed, So the velocity according to Chase's formula is given as, if we write the formula of velocity, okay, the velocity according to Chase's formula is given as V is equal to C under root mi, where V is velocity, C is Chase's constant, m is our hydraulic depth and I is slope of the bed. We know that the formula for m, hydraulic depth, is area by area of the flow by wetted perimeter, So substitute these values over here. V is equal to C into under root A by P into I. See, from this equation what we can say? Maximum velocity. The velocity increases, velocity of the flow increases if A by P, if the value of A by P is maximum for constant value of I and constant value of Chase's constant. If the value of I and value of C is constant, the velocity of flow V increases with increase in value of A by P, keeping the value of Chase's constant and slope of the bed I as constant. So V increases, V will be increasing, V increases if the value of A by P is also increasing, V increases if the value of A by P is increases. Look at the figure. See, diameter is constant, radius is constant, depth of the flow will be varying on theta. Here in the circular channel, the only parameter which we have to adjust is this angle subtended by the center by water at the center by the water surface. The only parameter which changes in the circular channel is nothing but theta. So if we differentiate the value of A by P with respect to theta, if it's equal to 0, then the value of A by P becomes maximum. Okay. So the maximum value of A by P is obtained when it is differentiated with the only parameter theta. So derivative of A by P with respect to d of A by P with respect to theta should be equal to 0, So on doing the derivative of A by P with respect to theta and equating to 0, we will be getting the maximum value of A by P. If we get the maximum value of A by P, then for constant value of C and I, the velocity is also maximum. Here in this equation, that this A and P both are functions of theta, So consider the value of area, wetted area can be given by the formula. Area of the flow of circular channel can be given by the formula A is equal to R square into theta minus sine 2 theta, theta minus sine 2 theta by 2. This is the value of area of the flow in circular channel, and the value of perimeter, wetted perimeter of circular channel is given by 2r theta. It is given by 2r theta. Wetted perimeter is given by 2r theta, and the area of flow in a circular channel is given by r square minus theta minus sine 2 theta by 2. We have seen that differentiation of d of A by P by d theta should be equal to 0. If we differentiate this equation, we will be getting as, if we differentiate this equation, we get it as P into derivative of A by P, dou A by dou theta, dA by d theta minus A into dP by d theta, A into dP by d theta by P square is equal to 0. We get this value by differentiating this above equation. So from this equation we can write P into dA by d theta minus A into dP by d theta is equal to 0, Keep this value in this box. Now try to differentiate this equation. And this equation. If we differentiate this equation, we get dP by d theta is equal to, theta value is 1, 2r is constant. We get only the value 2r. dP by d theta is equal to 2r, and from this equation, if we differentiate above equation, dA by d theta is equal to r square as it is, theta value is 1 minus sine 2 theta by 2 remains same. Sine 2 theta, the value differentiation of sine 2 theta is cos 2 theta into 2 by 2. This is the value we are getting by differentiating this area equation, and this is the value we are getting by differentiating perimeter equation. Wetted perimeter equation we got the value as 2r. Area equation we have got the value as r square 1 minus cos 2 theta into 2 by 2, which is equal to r square. This 2 and this 2 get cancelled. 1 minus cos 2 theta, 1 minus cos 2 theta. Okay. Let this equation be equation 1 and this be equation 2 and this be equation 3. Substitute equation 2 and equation 3 in equation 1. Okay. What we get if we substitute dA by d theta value and dP by d theta in this equation, we get P into, we get the value as P into, what is the value of dA by d theta? dA by d theta is r square into 1 minus cos 2 theta, 1 minus cos 2 theta minus A into dP by d theta is 2r is equal to 0. 2r is equal to 0. On simplifying this, we get the values as, on simplifying this equation, we get the value of, again this value of P and this value of A, again it can be substituted. P is how much? 2r theta. 2r theta into r square into 1 minus cos 2 theta minus, what is the formula for area? R square into theta minus sin 2 theta by 2 into 2r is equal to 0. On substituting both the values of P, A, dA by d theta and dP by d theta, we are getting this equation. On solving this equation, after solving this above equation, we will get the value as, 2r cube theta 1 minus cos 2 theta minus 2r cube theta minus sin 2 theta by 2 is equal to 0. See here, from here 2r cube can be taken as common, and if we send to the other side it becomes 0. This 2r cube from here can be taken out and sent to that side, so it becomes 0. Theta into 1 minus cos 2 theta minus theta minus sin 2 theta by 2 is equal to 0 by 2r cube becomes 0 itself. 0 by 2r cube becomes 0 itself. So next step is just multiplying these values. Theta into 1, theta minus cos 2 theta into theta into cos 2 theta. Just simply open the brackets of this equation. It comes as, if we open the brackets of that equation, you will get the values as theta minus theta into cos 2 theta minus theta plus sin 2 theta by 2 is equal to 0. How we are getting? We are getting from this equation, last line. Just we need to open the brackets. Just we need to do what we need to do. We need to open these brackets. This theta plus theta and minus theta gets cancelled. So theta into cos 2 theta is equal to sin 2 theta by 2. Sin 2 theta by 2 or sin 2 theta by cos 2 theta becomes 2. Okay. From here tan 2 theta is equal to 2. Tan 2 theta is equal to 2. So 2 theta from here, sorry, here one more theta is remaining. Okay. So 2 theta, here also 2 theta. So tan 2 theta is equal to 2 theta. So the value of, by trial and error methods, okay, by trial and error methods, the value of tan 2 theta will be around 257 degree. 257 degrees 30 minutes. So from here the theta will be 128 degrees and 45 minutes So this value of 2 theta we are getting with trial and error method, trial and error method. So the same value of tan, whatever the angle value of tan should be there, that should be equal to its numerical value. So from here we will be getting this 2 theta is equal to 257.30 257 degrees 30 minutes by trial and error method. So next, depth of flow for maximum velocity. Next condition is depth of flow for maximum velocity. As you can see, this is nothing but our depth of the flow. This d can be written as d is equal to OD. Okay, from the figure d can be written as OD minus OC. OD minus OC can be written from this figure. As you can see, OD is nothing but R and OC from this figure, from this rectangle, from this right angle triangle. If you notice this right angle triangle, the value of OC by applying this theta is nothing but this value comes as R cos theta. The value of OC is R cos theta from this right angle triangle. So D becomes, D is equal to R minus OD is R minus R cos theta, which is nothing but R, if we take common, 1 minus cos theta. The value of theta is 128.45. D is equal to R 1 minus cos 128 degree 45 minutes. Okay. So on simplifying this, on simplifying the above value, we get D is equal to R 1, the value of minus cos 128.45 is around 0.62 plus 0.62. So depth of the flow for maximum velocity D is nothing but 1.62 R, which is equivalent to, if we write in terms of capital D, this R can be written as D by 2, 1.62 into D by 2. So small d in terms of capital D, depth of the flow in terms of diameter is 0.81 D. This small d is depth of the flow and capital D is diameter of the circular channel. Capital D is diameter of the circular channel. Now to calculate hydraulic mean depth, okay, hydraulic mean depth, that is M, for maximum velocity, we know that hydraulic mean depth, the formula of hydraulic mean depth is area by perimeter. The area of circular channel, area of flow of circular channel can be given by R square into theta minus sin 2 theta by 2 by the wetted perimeter. Wetted perimeter is 2r theta. Wetted perimeter is 2r theta. So this value becomes, if we cancel r and r square, so this value becomes r by 2 theta, r by 2 theta 1 minus sin 2 theta by sin 2 theta by 2. This is the value of M. Now what we have got the value of theta? We have got the value of theta as 128 degree and 45 minutes. 128 degree 45 minutes. Okay, this minutes, if we want to convert it into degrees also, thus everything should be in degrees. So it becomes 128.75 degree. 128.75 degree. So to convert this value into radians, what we need to do? We need to multiply with how much? Pi by 180. 128.75 into pi by 180. The value will be coming in radians, that is 2.2 2.2 247 radians, 2.247 radians. Substitute this all values in the formula of M. So, substitute this all values in hydraulic mean depth formula. M is equal to R. R is as it is R by 2 into theta. Theta in terms of radians, 2.247 into 1 minus sine 2. Here theta we need to apply as 128.75 by 2. So, from here we get the value of M is equal to, if we solve this above equations, we will be getting the value of M in terms of R. So, it is 0.611 R, 0.611 R. Substitute this value in terms of D by 2, capital D. 611 R can be written as diameter by 2, diameter, this is D, diameter by 2, R is nothing but D by 2. So, this value becomes 0.30 D. So, therefore, M is equal to 0.3 D, 0.3 D. What from this equation, what we can conclude? 0.3 D. So, from this equation we can conclude that maximum velocity is only obtained in a circular channel when hydraulic depth is 0.3 times of diameter of the circular channel. So, this is nothing but maximum velocity condition. The maximum velocity in the hydraulic, the maximum velocity in circular channel is only obtained if hydraulic mean depth M is equal to 0.3 times of diameter of the circular channel. So, this is all about the first condition. When we are getting this maximum velocity, we are getting this maximum velocity. This condition 1 we were deriving, we will be getting condition for maximum velocity is hydraulic depth should be equal to 0.3 times the diameter of the circular channel. Now, let us derive these conditions for maximum discharge. Now, let us derive the condition for maximum discharge. Now, after deriving the conditions for maximum velocity, now derive the conditions for maximum discharge. Condition for maximum discharge. Condition for maximum discharge. According to Chase's formulas, discharge can be given as Q is equal to AC under root Mi. AC under root. The formula for discharge according to the Chase's formula is Q is equal to AC under root Mi. Similarly, we know that M is equal to A by P. Substitute Q is equal to AC under root A by P into I. Okay. Take this A inside the root. So, it becomes Q is equal to C into under root A cube by P into I. A cube by P into I. See this A, if we go inside the under root, it becomes A square. A square into A is A cube. So, when the value of maximum discharge will be, we will be getting the value of maximum discharge if A cube by P value is maximum. A cube by P value is maximum. We will be getting the maximum discharge when A cube by P value is maximum. So, the value of Q will be maximum only if A cube by P is maximum, and A and P, these both are functions of this theta. A and B are functions of this inclination angle theta, where C and I values will be constant. So, if we derive A cube by P, derivative of a cube by p with respect to theta should be equal to 0, should be equal to 0, should be equal to 0. So, if we derive this, what we will be getting on doing the derivative of a cube by p with respect to theta, we get it as p into 3a square into d a by dp minus, sorry, dA by d theta minus a cube into dp by d theta divided by p square is equal to 0, divided by p square is equal to 0. So, this is the result of differentiation of a cube by p with respect to theta. So, from here the value we get is 3a square p dA by d theta minus a cube dp by d theta is equal to 0, is equal to 0. Treat it as equation 1. Treat it as equation 1. Treat it as equation 1. We know the formulas of A and P, and also we have derived the formulas of A, dA by d theta, dP by d theta, and A and P. So, just we will write it from our previous findings. From previous findings we have written all this. So, what is the value of see, you can see equation 2. Equation 2 is dP by d theta is 2r, dA by d theta is r square 1 minus cos 2 theta. Just look at equation 2. Okay. So, first of all, let us write the values of A. The value of A can be written as, the value of A is area of circular channel is r square theta minus sin 2 theta by 2, whereas dA by d theta, here we have done, here we have calculated dA by d theta is r square 1 minus cos 2 theta, r square 1 minus cos 2 theta, r square 1 minus cos 2 theta. And we know that value of P is 2r theta, and the value of dP by d theta is 2r, d theta by value of P is 2r theta and dP by d theta is 2r. Substitute this all values, in this equation 1. Substitute this all values in this equation 1. Okay. If we substitute the value of A, dA by d theta, P and dP by d theta, we get the value as, so on substituting this all values into this equation 1, we get it as equation 1 transforms as follows: 3 into 2r theta into r square 1 minus cos 2 theta, okay, minus r square into theta minus sin 2 theta by 2 into 2r is equal to 0. 2r is equal to 0. On solving this equation by trial and error method, solving this equation with trial and error method, we get the value of theta as, 154 degrees. We get the value of theta as 154 degrees. And we also know that the depth of the flow D, depth of the flow D is r minus r cos theta, which is equal to r1 minus cos theta. Okay. So, on substituting the value of 154, that is r1 minus cos 154, we get 154 degrees. We get small d as 1.89 r. Okay. If we substitute r in terms of d by 2, 1.89 into d by 2, we get the value as 0.95 d. So, d small d is equal to 0.95 times the capital D. This is the condition for maximum discharge. For the condition of maximum discharge in an circular channel, okay, the depth of the flow should be equal to 0.95 times the diameter, 0.95 times the diameter of circular channel. So, here we have derived this condition too. So, now let us write this condition also. For here small d should be equal to 0.95 times the capital D. 0.95 times the capital D. For maximum velocity, hydraulic depth should be equal to 0.3 times the diameter of circular channel. For conditions for maximum discharge, the depth of the flow should be equal to 0.95 times the diameter of the circular channel. Hope you have understood about the most economical circular sections. In next classes, we will be solving numerical examples on most economical circular section, most economical trapezoidal section and most economical rectangular sections. Hope you people have understood.